Good morning, everyone. I'm going to start the discussion on the equivalence of various regular expressions. This lecture is very important from GATE point of view because multiple times in GATE questions has been asked on the equivalence of regular expressions. So please do try to understand and make sure that you are comfortable with this particular topic. So now let's start the discussion. Uh, Here I have taken some of the regular expressions as an example, like whatever the symbols I have taken here, R1, R2, R3, all you consider as these are regular expressions. Okay. Now, so if there is a regular expression R1 is given, and if you perform OR, so if you write R1 or R1, you will get R1 only. We have already seen in the previous lecture. If I write R1 concatenated with R1, it will not be equivalent to R1. It is also we have seen in the previous lecture. If R1 we perform union, or you can say or R1 or R2, we can change the order. We can write the same thing as R2 or R1, right? That thing also we have seen in the previous lecture. If I write R1 concatenated with R2, and if you change the order R2 concatenated with R1, it will not be equivalent. That is also we have seen in the previous lecture. R1 union with phi will give you R1 only, or if you do phi union with R1, that will give you R1 only. This is also we have seen in the previous lecture. Epsilon concatenated with anything, whether it is any of the thing from either left side or right side, it will give you the same regular expression. So that is also we have seen in the previous class. Now this associativity property like R1 or R2 or R3, you can associate in any of the manner, they will be equivalent. That is also we have seen in the previous class. R1 concatenated with R2 concatenated with R3, or this, if you change the order of concatenation, then also they will satisfy. So associativity is satisfied over union as well as concatenation both. This is also we have seen in the previous class. Now in case of distributive, this concatenation operator is distributive over union, but union is not distributed over concatenation. So if you write this thing R1 dot R2 or R1 dot R3, it is equivalent, that we have seen in the previous class. But if you write R1 or R3 dot R1 or R2 or R3, then it will not be equivalent. That is also we have seen in the previous class. So all these things we have already discussed in the previous lecture. Now look at something new. Let's say you are having phi. This is also we have seen. So I have just included few of the things. Phi dot R1. If you concatenate the null set phi with any of the regular expression in any of the manner, like left side or right side from, or if you have the cleans closure of that regular expression R1 star dot phi or phi dot phi, or if you have positive closure of phi, you will get phi only. So this is important thing. Please do remember, this is important. This is very important. Okay, please do remember this thing. It is quite important relation or equivalence relation, right? Then if you put cleans closure on phi, you will get epsilon. So this is very important. Please do remember this thing. Now what it is giving, actually phi is a null set. Phi is a null set. Phi is a null set. So null we have to represent by a symbol, right? If you put null set and if you put like asterisk on this, so at least null is there inside this, and if you put the asterisk, it will give you null symbol. And if you combine this null and number of times, then also you will get null. Okay, but in previous case, you just look at here, I'm not writing here phi star, because phi star will not give you phi, it will not give you phi set, it will give you null symbol. Please make sure that you understood these two things. So what I'm trying to say is, it is not equal to phi plus. Okay, phi plus will give you phi, but phi star will give you null or epsilon. Please do remember, this is very important. Okay, right? Like this. Okay. Now move on to the next. If you put the cleans closure on null symbol, it will give you null only. If you put positive closure on null, it will give you null only. So there is no variation, but in case of phi, you just remember this. If there is a regular expression R1, you do the cleans closure of it, concatenate with the same cleans closure of R1, you will get R1. Because if I am writing R1, R1 is a regular expression, it will generate a certain number of strings. If I write cleans closure of that set, cleans closure of R1 means the cleans closure of a set which is represented by R1. So if already you have put in the cleans closure of that particular set, that means every possible string over that particular set you have already defined. So if you write the concatenation again the same thing, nothing else, nothing extra you are going to generate. Okay. So in case I am having a set, let's say I am having A comma B, and if I write let's say R1 is defining something, let's say AB, BA, AA, BB kind of thing. So R1 is defining these strings only. Okay. Now if I write R1 asterisk, all the combination of this starting from null, anything like AA or AB, BA, BB, and then combining like so, the 4 length, 6 length, and so on, you are generating. But if I write R1 asterisk dot R1 asterisk, nothing new I'm going to get, because whatever the things are possible with these combinations, you have already included in the R1. So if you start combining R1 star with R1 star, the similar kind of thing you will get. I hope this is clear, right? So I'm just cleaning it. Okay. Now, so this is, I hope you are clear. If you are writing R1 cleans closure concatenated with R1 positive closure, then you will get positive closure, because this may be null, this may give you null, but it will not be null. So at least you are going to get R1. So null concatenated with anything will give you that particular thing. So this is also clear, I hope. Now R1 star to the star, R1 cleans closure to the cleans closure, or you write R1 cleans closure to positive closure, or you write R1 positive closure of cleans closure of it, it is equivalent to R1 star only. The same thing is happening here, because R1 star will give you every possible string over R, every possible, in any of the manner, any combination. So if you are saying R1 star is every possible thing, and every possible thing you want to write every possible thing of every possible thing, it will be every possible thing only, because whatever the possibilities we have already considered in R1 star. So if you put R1 star to the power star, it is only R1 star, right? If you are writing every possible thing, positive closure, it is going to give you every possible thing, right? If you write positive closure every possible thing, that means it may generate null also, then every possible thing. So it is never going to beyond the boundary of the R1 star, because it is the universe over a particular alphabet. So I hope this is also clear to you, right? Then R1 dot R1 star, that we are already aware about. R1 asterisk or cleans closure dot R1 will give you R1 star. So please do remember, this is important property. We have discussed, I guess, in previous class. Epsilon or R1 dot R1 star. So this will give you R1 positive, R1 plus, right? We have seen here. So we can write epsilon plus R1 plus, this easily can be written. And R1 just missed out the epsilon. R1 में epsilon नहीं होता है, null नहीं होता, right? So in R1, if you include epsilon, it will be equivalent to R1 star. So I hope this is also very much clear. Now if I write R1 asterisk dot R1 positive closure, it will always give you R1 closure, because this may be null, but this is not going to be null, right? So this is also fine. we have already seen here. So ये repeated लिख दिया मैंने, चलिए इसको मैं clean कर देता हूँ, right? So this is already we have discussed, so you are aware about here we have discussed. Then R1 plus R2 asterisk, R1 asterisk, R2 asterisk. So if you write R1 union R2 and every possible thing over R1 and R2, every possible thing. So if you put asterisk R1 or asterisk R2 and put this thing, because it is not going to be beyond the limit of R1 plus R2 asterisk, it will be equivalent to this. So this set and this set will be equivalent, whatever will be generated. Similarly, this thing, if you write R1 asterisk or R2 asterisk, whole asterisk means cleans closure, this is also be equivalent. This is important property, please do remember. R1 concatenated with R2 concatenated with R1, and this is like cleans closure under this. Or you write R1 dot R2 cleans closure R. This is very, very important. Once it has been asked in GATE exam also. So this is very important. How you can validate it very easily. You consider like R1 is having some value, R2 is having some value. So let's say R1 is having A. You can take any bigger value also. That's not a problem. And R2 is having, let's say, B. Okay. So if I write this thing will give me A, B, A asterisk. I'm saying this will be equivalent to A, B asterisk, A. That means whatever the possible string, this will generate this regular expression. The similar set of strings it will generate. No extra string can be generated by this. You can test it. So if you repeat it once only, it will generate single A. Similarly, if you consider this asterisk is null, that means it will also going to be generate single A. If you repeat it twice, it will generate A, B, A, B, A. Or if you repeat it once, it will generate A, B, A. Similarly, this will generate A, B, A. If you repeat it once, if you repeat it twice, it will generate A, B, A, B, A. If you repeat it twice, it will generate A, B, same thing, right? A, B, A, B, A. So similarly, this will generate the same set. Okay. So please do remember. Now the next thing is R1 or R2 asterisk. That means every possible string over R1 and R2. Simple thing. So if you add anything extra like R1 asterisk or R2 asterisk, it is not going to change the set, because already you have considered every possible string over R1 and R2. So this portion is extra only. So simply you can write this thing. This is important. Please do remember, right? Then let's say if I write a language over R1, R1 is a regular expression, union R2, I can simply write a language of R1 union language of R2. This is easy to understand, not very difficult. Similarly, same thing we can write on concatenation. So if I write a language over R1 concatenation with R2, where R1 and R2 both are regular expression, I can write L1 like LR1 concatenated with LR2. The same thing, it is equivalent to each other. Now if I write language of R1 star, if I write language of R1 and put whole star, it will give you the same thing. Okay. Now if I write R1 star or I close it something like this, this is equivalent. Like it is not very difficult to understand, right? So this thing is fine. These are the easy thing. Now let's solve few previous year GATE questions on the similar concept. So one question has been asked in GATE 1992. Now, which of the following regular expression identities are true? Now they are saying R is a regular expression, but you are putting inside the bracket star is equal to R asterisk. So this thing, because single asterisk you cannot put, this is an operator, it requires something. So these brackets are not the symbol, then you cannot write something like this, right? You do the cleans closure of some symbol, but if you write something like that, this is not. So we cannot say this is equivalent, we cannot say, because simply we cannot write something like this. This is, we have already seen, R1 asterisk or R2 asterisk. Here they are writing R or S asterisk to whole asterisk. This will give you, so this is fine, this we can write as we have already discussed. R1 or R2, or you can say R or S whole asterisk, we cannot write This is not like digextras kind of property. It does not satisfy. So you cannot apply directly star here and star here. So this will not be satisfied. Please do remember. Why it will not be satisfied? You can also validate it, because here it is a flexibility. You can take a string from R1 and then from S, and then you can combine the different set you can generate. If you take some example of R and S and you start generating from this and start generating from this, you will get some of these strings will be different, right? So please do remember, this is not equivalent. You cannot write like this. Now same thing here. This concatenation R star concatenation with as a star, you cannot write like this. This will not give you the same thing. Okay, this will not going to give you the same thing. If you want to equivalent it, you need to put whole asterisk. If you put whole asterisk, then it will start giving you the same thing, right? So the answer will be B. Answer will be B. Okay. Now, the last, which of the following regular expressions are equivalent? So this is very easy thing. Now this regular expression, the very first one, it is having this thing will generate even number of zeros. So either 0 times 0 or 2 times 4 times 6 times and so on. If you are combining with null, that means this with null is going to give you even times 0. And if you combine this thing with 0, it is going to give you odd times 0. So that means it is going to generate either even times 0 or odd times. Okay, so this is only going to generate you even times, this is only going to generate odd times. That means this is generating all the things, even and odd both. So that means the answer should be C. 1 and 3 will be equivalent. Now, which of the following regular expression is not equivalent to the regular expression A or B or C, or you can say A union B union C, where A, B, C are, you consider as the regular expression, whole string. So whatever the things it can generate, I told you na, like this thing is similar. Like we have discussed R1 or R2 whole string. You can say R1 string or R2 string whole string. So this is equivalent to this, not a problem. Similarly, this is also equivalent to this, not a problem. And this thing here, there is a boundation on AB. Altogether AB need to come. So this will violate the thing. This is very easy. So this option is not going to equivalent. And because any of them we can make it null. So if we do not want B, we can make it null, and A combination, all the A combination with, and if we don't want A, we can make it null. So this is also going to give you the similar. So that means answer is going to be C. It is not equivalent, not right. So I hope this lecture will be useful for you. Thank you everybody. I'm closing the thing. See you in the next class. We'll practice few more things.